Module, I'm going to go through and show another example of how we can take measured feature data. Up in this area here, there are just some surface points, and how I'm going to blend that into this CAD model here that I've already prepared. So if you haven't seen the module where I've measured these surface points, go ahead and check that out. And if you haven't seen the module where I've prepared this CAD model, be sure you check that out as well. Both of those would be beneficial before looking at this module here. But let me run to review features here a second. Now notice I've got these 4 surface patches. I'm going to go view them a second and then zoom in. One more time there. Alright, now notice I've got my A patch, which is this surface here. I've got B that's underneath this flange here and underneath this tab here. And C is going to be this trim edge right here. So I'll zoom out just a little bit more. And then here are all of my measured points that I've captured as surface points. Notice that this is a measured surface point. Now, what I'd like to do is associate those points to the surfaces where they are related to. So I'm going to take all 3 of these datum A points, highlight them all at the same time, and I'm going to go to the Nominals tab here. And then what I could do, since I know what I've named it, I've named that the nominal datum A surface. So I could pick it from there. But say I didn't quite remember what I named it, or I've got so much data out there I can't remember which surface that was. I would go right to this icon here, which is a choose from the screen, and I know that they were in this area here. So when I click on that, notice what comes up. I've got a face here, that's the back of the material, and here's the datum A surface that I've selected earlier when I was preparing this model. So I'll hit that. Now notice what it's done is it's grabbed all 3 of those points and it's made this nominal surface associated to them. Alright, then I'll do the same with B1 and B2. I'll go here to datum B1 and I will run over here and I'll select this one here that I've already named. There it is, the nominal B1 surface. Do the same with B2. I'm just going to associate a nominal surface here, B2. And then datum C, I'll go right to the datum C surface. Alright, now all of those features have a nominal associated to them. Well, that's what I like. I'll hit OK on that. And then what I'm going to do is I'm going to run right up here to the alignment menu, pull that down, and I'm going to find the iterative alignment. Okay, now here's all the features that I want to use to solve for the iterative alignment. I'll highlight all of them, and I'm not going to set weights. I'm just going to let this float, and I will say OK. Now notice what happens in a quick sort of way. I'm down to about 1/10 of a thou right now. Actually, that's 1/10 of a micron. I think that would be, because I'm in millimeters here. So there it is. That's the alignment 001. And I would expect that to solve pretty close. Those features that I put on there are pretty square to each other. So if I say OK now, notice what happens. The points just appeared from the other coordinate system, or from just the local measurement where I was close to the arm. And now it's moved those points into this vehicle location, or the vehicle coordinate system now. So notice I had some points up here. Now they're actually all on the part now. So that's what the iterative alignment has done, is it has moved those points to where they needed to go on the part. So now to prove that to myself, I'm going to go back to review features a second, and I'm just going to highlight this datum A1. Notice what it's done. It's taken the measured point, it's associated it to the nominal surface, and my deviation is nothing. It's absolutely nothing. It's right on the surface patch. So all 3 of those datum A's should have a deviation of nothing. There's my 1/10 of a micron here. I guess that shows up. But as close as it could get them to their surface patches is how it's moved them. Both my B's, they should be down to 0, so they've solved for 0 on the surface. And then C, which is the trim edge. Let me go view that a second. Notice that. It's right on that trim edge. So that is solved for 1/10 of a micron here as well. So that is truly in the CAD data alignment using the iterative. So I'll say OK to that. And now what I could do is start to measure some inspect surface points, or do some sheet metal points, sheet metal trimmed points on these trim edges here, if that was something I wanted to check for a profile of surface. But using that iterative alignment, it's very fast. And the way I've done that was measuring surface points first, and then associating those surface points to the surfaces on the part, and then just going back to the alignment iterative.